So we have seen the client server architecture, the distribution time taken. So it is given by where the distribution time should be greater than or equal to the maximum value, where F indicates the file time, N indicates the number of peers that is involved or number of clients that is involved, and daemon is nothing but the download, minimum download time that is taken by each and every peer in order to download the file. And this is what the time, and it linearly increases depending upon the number of peers that they will be keep on connecting to the network. In the same way, we have seen the file distribution time for the peer-to-peer architecture, where in case of peer-to-peer architecture, only one time the server is going to upload the file that is required. Then the peer, it is going to take the responsibility of distributing the file across the network. And we have seen the distribution time for the peer-to-peer architecture, where this is one. So this is the formula that you can see, where you can able to identify, you can able to see that the time taken, that is a distribution time taken in order to upload a file or distribute a file across the different peers in the peer-to-peer architecture. And after observing both the scenario, the client server architecture as well as the peer-to-peer architecture, we have seen that compared to client server architecture, the distribution time taken for the peer-to-peer architecture is very less. So where the server, it takes 10 times more than the client in order to upload the content to the peers or the clients that is connected in the network. Okay. So I have started with the BitTorrent, one of the application of the peer-to-peer architecture, where torrent is nothing but a collection of peers that is involved in the distribution of the file, or group of peers that they are exchanging the chunks of the file, that is called as torrent. And tracker is one who is going to track the peers that is involved, the people, the peers that is alive, the peers are entering or exiting. So everything it is going to keep track. Okay, so and we have discussed a scenario that is with respect to Alice and Bob, and we have seen that there will be choked, unchoked, as well as optimistically choked peers. So the unchoked peers is nothing but, so whenever a peer or allies request for some chunk of file, so then immediately who are the peers that is going to reply back to the allies, those peers we are going to call it as the unchoked peers. And one who keep on providing or satisfying the request of the allies, or any peer one who requests, okay, one who keep on serving the request of a particular peer constantly, and he will be at the top. Okay, then that peer we are going to call it as the optimistically choked peer. Optimistically unchoked peer, it's not choked peer. Okay, and the choked is nothing but the peers who's not involved in sharing the chunks of files. Okay, it may be with the allies, or it may be with the any other peer that is connected in the network. So usually every 10 seconds this peers will be keep on changing. We are going to evaluate whether who is at the top 4. So if no one is involved, then those particular peers we are going to call it as the choked peers. Okay, and every 30 seconds randomly select another peer, start sending the chunks. Okay, suppose if any people other than 4, if they need to reply or send back, then you can choose that particular peer in order to receive the whatever the chunks that it is able to provide. Okay, for every 30 seconds, so that will be done in order to exchange the peers. Okay, and we have seen the scenario where in this particular scenario allies will be requesting, and the Bob is one who's at the top 4, who's always providing the response or the chunks of file to the allies. So that's why the Bob is said to be the optimistically unchoked peer. Okay, and so this is about the BitTorrent. So this is one of the application that comes under the peer-to-peer architecture. So there is also one more application, that is the distributed hash table. So this is also for the peer-to-peer itself. This is also one of the example of peer-to-peer architecture where you are distributing the file distribution protocol. This is one example that comes under the peer-to-peer architecture. So here in this distributed hash table topic, we are going to discuss about the hash table, the DHT, distributed hash table paradigm, and then circular distributed hash table and the overlay networks, and then the peer churn. Okay, so now let us consider a simple database. Simple database, where the simple database, it contains the key and the value in the table. So the key indicates the human name and the value indicates the value, it may be the IP address. Okay, or here in this example, in this table, the key is said to be the human name and the value is said to be the social security number. If generally, if we consider a network, so usually the key will be the system name and the value will be the IP address. Okay, the peer name or the IP address. Or if we consider some other example, so the key will be the movie title and the value will be the IP address. It depends on the different application. Okay, so here in this table, it is going to maintain the human information, that is human ID information or a person ID information, where this table consists of the human name as well as the value as the social security number. So whenever if you want to identify a human, so usually with the help of the key value, it is going to identify a person or a human with the help of the key value, that is the human name. Okay, in the same way, suppose if you want to search a movie, okay, in a set of databases that is present, so by giving the key value, so usually suppose if you switch on your YouTube application, suppose if you want to watch a movie in the Netflix or in the Prime Video, Amazon Prime Video, so what you're going to give, the key value you have to give is the movie title. So like that. So just an example I'm telling. So here, if you want to search, if you want to search anything like a human value or a peer name or uh, nothing but movies, so like that, so you need some key value. Okay, so like in DBMS you'll be having the primary key. For example, how you're going to identify a student uniquely, you'll be having the primary key called as the USN. Okay, the university seat number. Okay, and then in the same way in the employee database table, so how you're going to search, so you, with the help of the employee ID, you're going to search. So in the same way, so each and every table will be having, or each and every database, it will be having its own key as well as the value. Okay, so like that. So even suppose if you want to search anything, you should have a key value. Okay, you should have the key, okay, where with the help of the key you can able to fetch the value. Okay, so here file distribution, the file distribution in the sense you can request a file, okay, as well as you can also send a file. You can request for a file that is that you require. For example, allies and the other peers that is connected in the network, so allies can request a file as well as she can share the file whichever that she is having with the other peers. So for that you need to identify, so how to identify that peer or how to identify that how to identify that file, so with the help of the key. But it is very difficult to identify the key. If there is multiple number of keys, it is very difficult to identify. For example, if you consider a library, let us consider Sai Vidya Institute of Technology, the library that is maintained in a college. So you want to search for a book, for example, Computer Networks, James F. Kurose, so he is the author. So you know only the textbook. Okay, you know only the Computer Networks textbook you need to search. So you will go to the library, you will go for different set of cupboards and you will be keep on searching. But it is very difficult to search because almost 10,000, 20,000 books will be maintained in a library. So how to search? How to search? You have the key. You have the key. The key is nothing but your textbook name. But only with the help of the textbook name, so it is very difficult to search. So that's why, so what they're going to do in the library, they're going to segregate the textbooks in terms of departments. So like CSE, ISE, civil, mechanical, electronics and electrical. So like that, they're going to segregate into different departments. Like that, they're going to segregate the textbooks into depending on the category, they're going to segregate the textbooks. Okay, depending upon the department wise, they're going to segregate the textbook. Now again, so again when we come for CSE, again computer networks related, for example, computer networks, data communication, or information and network security. So these are all related to one category in the computer science department. So that will be kept in one particular step or one particular part of the cupboard. In the same way, programming languages C, C++, Java, so it will be kept in one compartment. So like that you're going to segregate, so like in the form of category or different groups, so like that you're going to segregate. Okay, because it is very only with the help of the key value. So again, to identify a particular key, you need something. Okay, you need some primary thing in order to search for a search for anything. Okay, so like that we have seen in the library. So like in the same way, the hash function is one which is able to or which is able to provide the necessary information that is required for a user or a person or a customer. Okay, so if you apply a hash function, where hash function is nothing but it is one which is going to convert many to one. Means if you give many inputs, one output is fine to identify a particular file or to identify a particular textbook. Okay, so the hash function is nothing but which is used, which is one which is going to convert the many to one. For example, if you consider a dictionary, so A related words will be in one particular part and B related words will be in one particular part. So like that, in order to identify anything like a word or a letter or a textbook in a library or a human being, for example, human being name. So if it is sorted in the form of alphabetical order, then it will be easy to identify the human name. So like that, in order to identify this original key is nothing but your human name. So it is very difficult to search the human name. It is a key, but we need some primary key value to identify a particular person in this particular table. So what we have to do is we have to apply a hash function. Okay, the hash function where for many inputs you'll be having a single output. For example, many inputs in the sense, if multiple textbooks you want to search with respect to CSC, computer networks, and then information and network security. So these are the multiple textbooks. So this one you want to search in the library. You want to search in the library. So after applying the hash function, so CSC department is one solution. CSC department is considered as one key in order to search that particular textbooks, because those all comes under the one particular department, that is CSC department. So CSC department will be the hash key, and the textbooks whatever you're going to give is nothing but the input. So many to one, the hash function is one which is going to convert many to one. Means with the help of this particular category you are able to search the textbooks. So in the same way, for example, there will be multiple files. So one file start with digit 1, the other set of files start with the digit 2, then the other set of files it starts with the digit 3. So if we, on all the files that comes under 1 will be located in one particular block, and then the files that is starting from 2, it will be kept in other particular block, and in the same way 3, 4, 5, like that. So now if you have a key value called as 1, then where you have to search? You have to search in the first block. If you have the key value as 2, then you have to search in the second block. So where this 1, 2, 3, so these are nothing but the hashed keys. Okay, so in detail you're going to study about hashing algorithm in information and network security. Okay, so that is on some part you're going to study, that is security hash table and all. So just how this hash table it's going to work. So just I gave a simple example, that is with respect to library or dictionary, or how you're going to segregate your files in the form of keys. Okay, so where these keys are nothing but the hash keys. Okay, with the help of these hash keys, these original keys can be identified, that is the human name can be identified. Okay, so why this hash table is required? Because in order to store a file to a particular block, or in order to fetch or in order to search a file, okay, easily, so we need a numerical representation of the key. So that is done with the help of the hash function, and that key we are going to call it as the hash key. Okay, this is the general how a hash key will be helpful. So this is the general thing that I have explained. Okay, so so now we'll look into the distributed hash table. So distributed hash table, so usually while searching a file, or you want to keep a file, into the database, or if you want to search a file from the database, so you should have the key as well as the value, the key as well as the value pair over millions of peers, because in the network, so there will be multiple peers connected. I already told that so yesterday. So each and every peer is going to keep a chunk of file. In the same way, in case of distributed hash table or distributed hash table, so here it is going to maintain the information about the multiple peers, okay, that is connected in the network, and each and every peer will be having the chunks of files. So that's why it is called as the distributed hash table which contains only the key value, the pair value, but the distributed hash table, so which peer is having what information, okay, which peer is having what information. So how to identify a peer? The peer can be identified with the help of the hash key or with the key, okay. So that's why you're going to call it as a distributed hash table, because it contains the information of all the peers that is connected in the network, where the file information or the file content or the chunks of file will be distributed among the network. Okay, so suppose if any peer it requires a chunk of file, it can send a query, it can send a query to the database with a key. So where the database returns the value for the key. So to resolve the query, small number of messages will be exchanged among the peers. Yesterday we have discussed the allies and other peers that is connected. So we have seen that the allies, it is going to send a query. So where the query database with the key. So it's going to send a key that I need a chunk of file where the file number starts with 2. Then the peers, those who are having the files with respect to the second block, so they are going to reply back. So like that, the peers, they're going to exchange the messages in order to share the information or in order to share a content of a file. Okay, and each peer will be knowing only small number of other peers, because there is no any rule that all the peers should know, should be known to all the peers that is connected in the network. Each and every peer should know all the information that is connected in the network. Okay, because the allies, when it enters the network, so initially it doesn't know any peer. So only after sending a request, so whoever they send the reply, so only those peers will be in contact with the allies, and only the allies know only those 4 peers, because the other peers that didn't interacted. Okay, so that's why each and every peer, they'll be having only the connection, or only they'll be knowing only the small number of the other peers. Okay, and there is one case, the robustness. The robustness is nothing but there is one drawback here. The peers will be keep on coming and going, or they'll be entering and they'll be exiting from the network. So suppose if they need the file, they will enter the network, and they're going to collect the file from all the peers, okay, from different peers, and after getting, they can be in the network or they can leave the network. Okay, so that coming and going is nothing but the churn. That is the robustness. So even robustness in the sense, even if the peers come and go, so the network, uh, it doesn't happen anything, means nothing happened to the network, so it will be constant. So it will be always open for all the peers to enter and exit. Okay, that is the robustness of the peer. But only the drawback is, so if they keep on coming and going, so the thing is, the other peers, they should know, at least the neighboring nodes, they should know that the succeeding peer or the preceding peer, they have entered and they have exited. Okay, only that information has to be maintained. So that is one drawback here. Robustness means even anything failure occurs, if any peers come and go also, it won't affect any other peers that is connected in the network. Okay, the distributed hash table is one which contains the peers information in the form of key as well as the value. Okay, that is the pair value where the distributed hash table is going to maintain. So why it is called as distributed hash table? Because the peers and the data, whatever for a file it is there, so that will be distributed among the peers. Okay, so that's why it is going to be, we are going to call that particular hash table which is going to maintain the value as well as the key pairs as the distributed hash table. So the main thing, we are going to use the distributed hash table in order to search and store the file. Okay, in the database. So it will be very easy, or it will be easy to search, or it will be easy to store the file in a particular peer. So with the help of the distributed hash table. Okay. So now assigning the key value pairs to the peers. So rule, what is the rule? Assign the key value pair to the peer that has the closest ID. Okay, so we'll discuss so how to assign. Okay, so whenever you're going to assign a key or the value pair to a peer, what you have to do is you have to assign in such a way that so it should be closest to the some other ID that is already existing. So you have to choose. So we'll see this example. So then you will understand. So the rule is you have to assign a key value to the peer that has the closest ID. Okay, for example, you can see here. Now see here, there is 1, 3, 4, 5, 8, 10, 12, 15. There is 8 different peers that is connected in the network. So this is the circular distributed hash table. Okay, so here, now each and every peer should know who is its predecessor and who is its successor. Predecessor is nothing but who is the neighboring which comes before or which comes previous to this particular peer and which comes next to this particular peer. For example, if I am going to consider the peer number 3, so who is the predecessor is 1, who is the successor is 4. Okay, so assign the key value pair such that to the pair that has the closest ID. Okay, I'll tell what do you mean by this closest ID. And the convention, closest is the immediate successor of the key. Okay, immediate successor of the key. So whoever the closest ID is there, so there you have to assign the pure number. I'll tell. So ID space. So here at the ID space, it is from 0 to 15. Okay, 0 to 15. Okay, that actually we have taken as not 1, 12, 13. It is from 0 to 15. So it consists of 1, 3, 4, 5, 8, 10, 12 and 15. Total 8 peers are there. Okay, so now where you can see if key 11, suppose if a peer it needs to enter where the key value that is assigned for that particular peer is said to be 11, then you have to identify the closest ID in order to place that peer. Okay, so suppose if 11 is the key that you are going to assign to a peer. Okay, then you have to choose and you have to place that peer in such a way that where it should be closest to the peer 12. So here you can see peer 12 is there. So suppose if a peer has to join, then the closest peer to this particular key 11 is set to be 12 or 10. So I have chosen here as 12. In the same way, suppose if you are choosing a peer where with the key value as 9, then the assigned to the peer 10 means which will be its successor? Its successor will be 10, means the closest ID to the 9 is said to be 10. Okay. So in the same way, if the key is set to be 16, then assigned to peer will be equal to 1. So for the 16, the successor or the nearby the closest ID is set to be 1. Means whenever suppose if you have chosen any peer with the key and value pair, so where are you going to place that peer? So depending upon the closest ID, means at least the number, whatever the key value that you have chosen, it should be nearer. Either it should be a predecessor or it should be a successor. Here we have considered as the successor value and we have kept that particular key in the mid. Suppose if the key value is 2, then where you have to keep that peer? So it should be near to 3 or near to 1. Okay, usually here we have considered as a successor value. So the closest value to the value 2, the key value 2 is said to be 3. So that's why you can place the peer here. So that if you are searching for any peer, so it will be easy to identify that particular peer, what value it contains. So it will be easy. Suppose if you have the keys for each and every peer. Okay, so the distributed hash table. So the distributed hash table is one which contains the keys as well as the value. So the key to identify a particular peer in this example, and the value which contains the IP address, value which contains the IP address in order to identify that particular system. Okay, also it may the value may also have a file. So what chunk of file that it is having, that particular peer is storing, so even that information can be loaded into the value. Okay, so now we'll discuss about the circular distributed hash table. Circular distributed hash table, just whatever the network that is connected here, it is in the form of circular. So whatever the peers that is connected, so it is in the form of circle. So that's why it is called a circular distributed hash table. Okay, and each peer will be only aware of immediate successor and the predecessor. Now suppose if you consider the peer number 3, so it will be aware of the predecessor. Predecessor means the previous one, and the successor means the next one. Okay, so while distributing, suppose if the peer 3, okay, it needs to distribute a file to file 10. So what it's going to do, it can go in the clockwise or it can go in the anti-clockwise. Suppose if it needs to go in the clockwise, then it has to pass the file to the successor, like 3 to 4, 4 to 5, 5 to 8, 8 to 10, 10 to 12. So like that it needs to transfer the file from one peer to another peer. Okay, so now, okay, so see here, so like this. Suppose if mobile request for a file, and these are the peers that is connected in the network. This is the overlay network. Overlay network is nothing but a network that is built upon the another network, okay, where they are virtually connected, but they are going to make use of the infrastructure that is present in the network below it. So all of you please understand the overlay network. The overlay network means over means the above the other network. Okay, so the overlay network is nothing but a network that is built upon the other network, a network that is built upon the another network. So where this overlay network gets, or it will be working with the help of this, the network that is below it, means the overlay network, it is going to make use of the infrastructure of the network that is below it. Okay, for example, n2 and n1 is on the n2. So now n2, it is going to make use of the infrastructure that is provided for n1. Okay, so the n2, it is called as the overlay network, and it is one which is going to make use of the infrastructure below it. Okay, and these overlay network, these are virtually connected network. Okay, so now you can see here, this is already the routers, okay, and the switches, and then the modems and the systems, these are all are connected in the network. But here one more network, you can see the laser here, there is a one more network that is connected here. All are there, students?
Yes, ma'am.
Yes, ma'am.
Okay, so overlay network is one. So this is one particular network, it forms its own network because it needs to transmit some file or it needs to access some data from one particular peer. So now all these peers are connected because they are sharing some information with the person who is using the mobile here. See here, there is one laptop, second one, third peer, fourth peer. Okay, and then again it has been connected to the mobile. Okay, so like this, so all these peers, so mobile and then other laptops as well as other desktops, so they are going to form one overlay network, on already a network is there, so there is different set of network is there that is connected. Above that, there is a one more overlay network that is connected for better communication or for their own personal communication. One more overlay network has been formed in order to do the communication, or in order to fetch a file, or in order to fetch the data, or any mail transfer, anything can happen. Generally we can say that a communication is happening between the nodes that is connected in the overlay network, where it is going to make use of the infrastructure that is already there in the below network. Okay, so now, so here this is how the circular distributed hash table looks like. Okay, so now resolving a query. So what's the query? What is the value associated with the key 11? Okay, now let us think. There is 8 peers that is connected. There is 8 peers that is connected in the circular manner. Now, what is the value associated with the key 11? Okay, so how to identify? Already the peer is there, already the peer is existing, but who will be knowing that the peer 11 is existing? Who will be knowing that the peer 11 is existing? Only its immediate predecessor or only its immediate successor will be knowing about the value key 11. Now, so usually if we contact each and every peer, we'll come to know that so who is having the value, that is the key value 11, or what is the value associated with the key 11. Okay, so what it's going to do, the 3, what it's going to do, the peer number 3, it can ask its predecessor or it can ask its successor. So the 11 is not associated with either 1 or 4. Okay, what it's going to do, it is going to send that message to the successor, but successor is not having that information. So again, what the successor is going to do, it's going to transmit the question to the next node. Then the 5, it is going to transmit to the 8. Then 8 is going to transmit to the 10. Okay, 10 is going to transmit to the 12. So then 12 to 15, then 15 to 3. So it's not like that here. So actually what happens is the 15 doesn't reply, only the closest value whichever it is there, so that one is going to reply here. So how it is okay, you can see here. Okay, so initially the question was what is the value associated with the key? Means there is a peer called as 11 with the key. So that peer contains what information or what value? So the peers has to contact each and every other peer that who is having that particular value, who is associated with this particular 11. So 11 is near to either 10 or 12. So that's why what the 3 means, peer number 3, first it's going to contact its predecessor. So it tells that I don't have any key value associated with 11. Okay, then what it's going to do, just it will be keep on transmitting the information or the question to the successor. Either 10 can reply or 12 can also reply. So now since 11 is closely associated, means because the 11's successor is nothing but 12, so it is closely associated with the 12 because it is close to the 11, because 11 comes in between 10 and the 12. Okay, so 11's predecessor, sorry, successor is said to be 12, so 12 is said to be the closest value. So now 12 is going to reply that, 12 is going to reply that I am having the value. Okay, because the 11 is closest to the 12, so that's why 12 is going to reply that, so 11 is the closest peer to me. Okay, and then so this 12 is going to reply the value, so it's going to contact internally with the peer number 11 and then it's going to provide the value. So the provide the value is nothing in the sense the file. Okay, 3 requests for a file. So now the 12 is going to respond because the 12 is one which is directly associated with the peer number 11. So whichever the value or whichever the file that the peer is 11th peer is having, so that is going to be replied back. So this is how we are going to resolve a query. So when a query is asked in case of circular distributed hash table, so what it's going to do, initially it is going to ask the predecessor or the successor, and then it will be keep on transferring the messages throughout the network where all the peers are connected. Okay, so now, okay, so what is the total time taken? Okay, so that is big O of n messages on average to resolve a query when there are n number of peers. So suppose if a question is arrived, so what's the total time taken? Means how many messages that it has to transmit. So almost, so each and every pair, almost all the pairs will be involved until it gets the reply back. Okay, so that is big O of n messages on an average to resolve a query. So how many messages is required in order to get the reply is given by the big O of n number of messages on an average to resolve a query when there are n number of peers, because each and every peer will be knowing its predecessor or the successor. Okay, here in this particular application or in this particular case, so here it will be having only information about the successor. Okay, so like that, to search a file or to search a key or to search a peer. So this is one particular example, that is the circular distributed hash table is one of the example we can see here. Okay, so the drawback we have seen that, okay, it has to send n number of messages in order to search for a peer. Okay, n number of messages has to be generated, so it requires more number of messages has to be sent, and more time has to be more time is required in order to get the reply back. So much time is required in order to get the reply back. So that's why we have a solution. That, suppose if we create the shortcuts, it will be easy for us to identify or to get the reply very soon from the other peers. Okay, for example, here one, okay, it can contact the successor peer or succeeder, predecessor or the successor of 1 is 3, and 3 can contact 4, and for each and every pair a shortcuts will be created. So 1 to 5, and then 3 to 8, 4 to 10, 5 to 12, 8 to 12 again, and then 10 to 1, so 12 to 3, and 5 to 4. So like this a shortcuts will be created. Okay, if suppose if any question arises, then it can solve easily by contacting through the shortcuts. Okay, so what is the value for key 11? What is the value for key 11? So what this 3 is going to do, it can ask its successor, but the successor says that, so I'm not associated with key 11. Then what? There is one more option. So it can ask the shortcut. So shortcut, what it's going to say, the shortcut is nothing but 8. The shortcut is nothing but 8. Now what this 8 is going to do? 8 is going to ask its successor. Okay, now the successor 10, it is near to 11. So it can respond, it can send a response back. Now the value that is associated with the 11, so it can send back the reply. Okay, so that it can reduce the time taken not to send back the reply. So for or a response time will be reduced here, as well as the number of messages here, only only 2 messages and 1 reply, 2 requests and only 1 reply, where here in the previous example we have seen how many requests, 3 to 4, 4 to 5, 5 to 8, 8 to 10, 10 to 12, 10 to 12, and then 12 back to 3. Okay, how many requests? 1, 2, 3, 4, 5, and 1 response. Okay, usually only 1 response. So totally 6 messages it is required in order to get a reply. But here within 3 iterations you got the reply back. So this is one method where you can reduce your response time, and then you can get back the required value very soon with a short span of time. Okay, each peer keep tracks of IP address of the predecessor, successor, as well as the shortcuts. So now 3 is able to contact either 1, the predecessor, or 3 is able to contact 4, the successor, and 3 is able to contact the shortcut. Okay, there is 3 possibilities. In case of the previous case, there was having only 2 possibility, either predecessor or successor. But here it can contact also the shortcut, where the response time will be reduced, as well as the number of messages that is involved for sending the response is also reduced. Okay, so reduced from 6 to 3 messages. So before it took 6, now it took only the 3 messages. Okay, possibility to design shortcuts with big O of log n neighbors and big O of log n messages in the query. So how many neighbors you need to contact means the time taken. So for sending the query and for sending the neighbors, it is given by big O of log n and big O of log n messages in the query. Okay. So this is about the circular distributed hash table with the shortcut. Now, what is this peer churn? The peer churn is nothing but the peers will be keep on adding or keep on entering the network and keep on exiting the network. That one we are going to call it as churn. Peers may come and go. That is called as churn. Okay. Each peer knows the address of its 2 successors. So here in this particular scenario, so each peer will be knowing the address of its 2 successors. Suppose for 3. So it will be knowing the address of 4 and 5. If we consider 4, it will be knowing 5 and 8. If we consider 5, it will be knowing the address of 8 and 10. So 2 successors. Okay. Now, each peer periodically pings its 2 successor to check the aliveness. So, in order to check the aliveness, whether your successor peers is existing or not, or alive or not, so periodically this peer, it will be keep on checking whether the 4 is existing or 4 is alive or not. So that is called as successor. Suppose if we consider if any immediate successor leaves, then what you have to do is you have to choose your next immediate successor as 8. Okay, if we consider an example, if let us think peer 5 abruptly leaves. So now let us think if the peer 5 abruptly, it leaves the network because it has completed its communication. Now it don't want to stay in the network. So at that time, so it can leave the network. So at that time, so for the 4, the immediate successor was 5 and the next successor was 8. Okay, now what it has to do, it has to do the changes. Okay, so peer 4 detects peer 5's departure, makes 8 its immediate successor. Now since 5 has been uh, left, so now the immediate successor will be 8 and then the next immediate second successor, it will be the 10, like that. So whenever a peer leaves, so it has to do this changes. Okay, so this is about the what is this distribution of file distribution. It may be file accessing or it may be sharing the file with the other peers, but to identify from which peer or to which peer. So in order to identify, in order to store on it, or in order to search, you need the help of this distributed hash table, where one scenario we have seen in case of circular hash table and circular hash table with the shortcuts. Okay, so this is how your circular distributed hash table is going to work. So next is your socket programming with UDP and TCP. So in the previous topic, we have seen the peer-to-peer application, where the peer-to-peer application with respect to BitTorrent and with respect to the distributed hash table. So we have seen the distributed hash table and then circular hash table. So what's the use of this hash function mean? So hash function is one which is going to generate a hash key, so many to one, which is going to convert the many inputs to single output. Means if you want to search a many textbook, then if you have a CSC as a category, then you can go to the CSC compartment and easily you can search. So that is many to one. So many textbooks you can search through a single category called as CSC. In the same way, many inputs can be converted to a single output. Okay, many inputs can be converted to a single output, so that is done by the hash function. In order to identify a original key, for example, human name, you need a primary key. So that key you're going to get by applying the hash function. We have seen the distributed hash table. So how it looks, usually it will be having the original key and the hash key as well as the value related to that. It may be the IP address or it may be the file name or anything. Okay. So next is the socket programming with UDP as well as TCP. Okay, actually I have discussed about socket. The socket is one which acts as an interface between the application layer as well as the transport layer. Okay, it is the door between the application process and the end-to-end process. So the main goal is how to build a client server application that can communicate using the socket. With the help of socket, how the communication is possible, we are going to study. Okay, here in socket programming, you're going to study with respect to TCP as well as with respect to the UDP. Okay, we're going to study. And one more thing, the program, there is two programs, that is experiment number 3 as well as 4 with respect to socket programming, that is with respect to UDP and TCP IP. So that one we are going to study in the next class. Okay, that will discuss in the next class about socket programming, that is with respect to UDP and TCP. And in the next lab, we will discuss about the socket programming itself, socket programming in the computer networks lab. Okay, so how the socket is helpful for communicating in the network with the help of the UDP protocol as well as the TCP protocol. Okay, so in the next class, we'll see socket programming in detail. Okay, and before leaving the class, you should know, tomorrow I'll ask the question about the UDP and TCP. Okay, just go through this UDP and TCP protocol, and tomorrow you need to answer about the UDP as well as the TCP protocol. Now we'll wind up the session. Is that fine? Have you understood, all of you? Students?
Yes, ma'am.
Okay. Okay, fine. So just I will record the attendance.